So this is 1.5 properties specifically for addition and subtraction, all right? Right here, identify, I'm sorry, that's not identify, identity property of addition. These are phantom zeros. So what this means is generally we look at this as it only going from left to right, okay? Even like this one. But it means that if you have an individual value like this, you could write it as a plus 0. Okay, so it also means that there's all kinds of plus zeros out there in mathematics. They're out there. You just can't see them, which is why we call them phantom zeros. So phantom zeros, they're out there. They're watching. They're always watching. You can't see them, which kind of makes them a little creepy, okay? But phantom zeros do exist, whether you can see them or not. So if you prefer to see them, feel free to write it in as just a plus 0 like this. Now, I may be making light of this more than I should, but this principle, the identity property of addition, is crucial because if we ever see a plus 0, it is possible, it is appropriate even, just to make it a phantom 0. So you could say, you know what, I don't want to look at that 0 right there. I don't want to look at the plus 0 for that matter. I just want to see it as A, and that would be acceptable. Now for the homework, we're going to see this more as a fill-in-the-blank type problem. And I will say that, again, it shows that the reverse is true, meaning A could be written as A plus 0. And A, by the way, is just, it's some number. It doesn't matter what number you choose. It can even be a decimal or fraction for that matter. But whatever number you choose, if you add 0 to it, you get itself back. That's all. Anything plus 0 is itself. So with fill-in-the-blank situations, we're just using the property. So 42 plus 0 is itself 42. So 29 equals what plus 29? Well, since it's the same value, 29, it has to be a 0 right there. That would have been that phantom 0. Now, it doesn't matter how big the number is either, even if it's like 892 right here. 0 plus what is 892? It means anything plus 0 is itself, so that has to be 892 in this blank. But we also have the subtract to get 0 property. Now, the identity property of addition is pretty crucial, but this one I would say is even more crucial once we get into the algebraic type stuff. I know we're just in arithmetic right now, but if you can understand that something minus itself is 0, and I'm not being sarcastic, if you can understand that, you can go very far in mathematics, okay? Because what's going to happen is when you subtract the value from itself, that's just going to become a phantom 0, is what that's kind of the point of this property. I know this is, that's quite far into the future, but it's still very important, okay? So we need to understand anything minus itself is 0. This example is pretty good. Again, I like the money examples. $5, you spend $5, how much do you have? $0. That makes sense, hopefully. So more fill-in-the-blank type examples with the subtract to get 0 property here. So 29 minus what is 0? It'd have to be minus itself, so that's a 29 right there. 96 minus itself has to be 0. So what minus 785 is 0? Well, that'd have to be 785. All right. So we're not a lot of analysis on this stuff because we're looking at zeros or something minus itself on that. But it may take a little bit of analysis, especially when we see problems in the future with fill in the blanks. But well, it won't be dealing with zeros or something minus itself. We'll get to those. All right, the commutative property of addition. So commute, it's kind of like traveling, right? Commute means you're traveling, your commute to work, you travel to work. And yeah, I could be way off on my interpretation of this, but that's what I think, right? You're moving from one place to another, okay? Commute. The commutative property, it really tells us that the order that we add values does not matter, okay? Because, right, in this example, this is the abstract form of it, but if you took a number and added another number, it's the same thing as if you reverse the order right there, right? Like, think about this example here. If I said, well, I guess we got 5 plus 1 down there. I want to think about it different. I'm going to use a different example then, okay? So 4 plus 2. All right? So now if we use the finger example, you'd say, all right, I got 4 fingers up, and then a fifth of 2 more would make 6 fingers right there, right? Well, it doesn't matter if you put 2 fingers up first and then 4 fingers. No, you'd still end up with the same amount. 2 fingers up and then another 4 fingers. Boom, still 6 fingers. See that? So the order doesn't matter. Or in this example that they've given us, right? 5 plus 1 is 6. 1 plus 5 is 6. That's the same as having a $5 bill and a $1 bill. How much money do you have? Yeah, you'd have $6. Well, what if you had a $1 bill and a $5 bill? See how that it's a redundancy right there, right? 1 and 5, yeah, it's still $6. So it works with more than 2 values as well. That's going to be important to know. And that's where it really comes into a good use right there, is when we start seeing lots of values added together. And yes, this is specifically addition on purpose. It works only for addition as far as the operations we've covered so far. But once you start seeing long problems with many values being added, it can be extraordinarily convenient to rearrange them, to commute them into a different order. So right here it says, rewrite the following with the commutative property of addition and simplify. When it says simplify, you could also say that it says solve, and that would be fine. So commutative means I'm going to change the order. So instead of a 2 in the first position and then 7 in the second position, I'd have a 7 in the first position and a 2 in the second position, like this. Okay, so that, I think on the homework like this would be what you would put into one box. Now the simplify box, 7 plus 2 is 9. And that would go in the second box. So when you see the homework, it's going to ask for both. It wants you to show that you've used the commutative property with these 2 values, and that you simplified that, which is just the answer right here, okay? So 8 plus 9, again, I'm going to commute the 2 and say that's now 9 plus 8. I just reverse the order. And again, that's what I would put in one box in the homework. And then the simplified answer here, 9 plus 8, 9 fingers up, another 8 fingers, 1, 2, 3, 4, 5, 6, 7, 8. I got 17 right there. So that would go in that second box. Okay. So 79 plus 24, we'll have to probably add these with some stacking on this one, but I'm just going to reverse the order. Now it's 24 plus 79. Okay, so again, this is only with 2 values, which, I don't know, it may seem quite elementary, but it's a pretty crucial skill to have when we start looking at bigger problems. So let's go and simplify this. So I'm actually going to add 24 and 79. Let's go and add these. 4 plus 9 is 13. 1 plus 2 is 3. Plus 7 is 10. So that's 103. Yep, that's the 2 boxes on this one. All right. Like I said, the commutative property it can be extraordinarily convenient if you're looking at bigger problems like we have right here. Right? Like if you're looking at 2 numbers, it's like, well, it didn't really help too much. But if we notice certain patterns with some of the addition facts, then rearranging it can be very convenient, right? Like this one starts out 6 plus 52 plus 91 plus 17 plus 34 plus 89 plus 8 plus 3. But we've rearranged it into 6 plus 34 plus 52 plus 8 plus 91 plus 89 plus 17 plus 3. And you may ask, why did we rearrange it with the commutative property? Well, the reason is because if we start looking at these in pairs instead of just one at a time, then I'd say, well, look, the 6 and 4 specifically is what I would be looking at in the ones position right here, right? 6 and 4 makes up 10. Which is going to add one of the 10s to the 3 right there, and so that's 40 right there. Okay, so there can be some usefulness, especially when we find that values can be added to base 10s. And so same with the 52 and 8 right there. The 2 and the 8 is 10. And then add that 10 to the 5 makes that 60. And then, again, the ones place value, 1 and 9, makes 10. So add that to another 9 and 8, which is 18. So that'd be a total of 180 right there. I'm skipping the stacking on purpose just to show that if you wanted to group them like this, you could. So in the ones place value for 17 and 3, 7 and 3 adds up to 10. So add 1 to the 1 there, makes that 20 right there. That's at 0. And yeah, if you wanted to add these values together, you could. Oh, and these ones stack up nice as well. 40 plus 60 is 100. And then 180 and 20, the 8 and the 2 makes up another 10. That's 200 right there. So when we add these together, we get the total of 300. Okay, now of course, are all numbers going to add up to something pretty like this, 300? No, of course not. But I'm just showing you that if you wanted to, you can group by tens or by ones to make 10 if you would like. And then like we showed right here, I did the 8 and the 2 to make 10 tens right there, which was another 100. Okay? Now you shouldn't see any problems as big as this one on the homework, but I'm just showing you that it can be convenient when you're putting together problems like this. All right, now I've grouped these kind of in groups of 2, right? That actually leads us to our next property. Oh yeah, this last one first though. The commutative property of addition. Why is it not the commutative property of subtraction? Because it doesn't work. Just think about this. If you did 18 minus, I don't know, 7, right? You'd get 11, okay? But let's switch it. Okay, I'm going to keep the minus sign, but I'm going to switch the numbers. So 7 minus 18, that's going to give you a negative number, and it doesn't really matter what it is. It's just that it's not 11, okay? So it does not work if we do use this with subtraction. Now later on, we're going to find a way to change subtraction to addition, which would then allow us to use the commutative property. But we're not worried about that right now either. So grouping. Grouping is the associative property. So when you look at problems like we did with that long problem, you can choose to group 2 at a time if you'd like. Okay, it doesn't matter where the 2 are, right? And if you need to commute 2 numbers next to each other with addition, you can, and then associate them, okay, or group them as you'd like. So you may start out with 3 different numbers and then choose to group the 2 second numbers. Now the parentheses indicates that we can do those first without actually changing the order, or you can group the first 2 numbers, A and B, like this, okay? So that's kind of the point of the associative property. It gives us the option to group 2 values together in a big problem, just like we saw on that last problem with the big one, okay? Now, again, there's no associative property for subtraction because, well, it has to do with how the subtraction sign affects the parentheses, but that's a different story, okay? But it does work for addition. So if you see addition, you can choose to group any of the 2 numbers. And again, we're only showing 3 values here, but it could be 4 values or 5 or 6 values. It doesn't matter. You can choose to group any 2 values that you'd like at any time, as long as you're looking at addition. The associative property isn't usually explained this way. Usually what they'll say is something like A plus B grouped like this. It equals A plus B plus C. It's just uncommon for people to start moving parentheses. You can, of course, which is what the associative property is telling us. But really what it means is if you start out with a problem, you can choose to group 2 values however you want, wherever they are. So right here it says, rewrite the expression using the associative property of addition and simplify. On the homework, you're going to end up with 3 boxes, and I'm going to explain all 3 boxes for each of these 3 examples, okay? So first off, and I should have mentioned this on the last slide, but the associative property will not change order. The commutative property does that, okay? So right here where I have the numbers 3, 5, and 6, the associative property will not change that order, even though it will change the parentheses. So I'd say 3 plus 5 plus 6. See how I did not change the order? Well, whereas this one grouped the 3 and 5 first, I could say, you know what, I'm going to group, I forget what I said, but it grouped the 5 and 6 first, but what I want to group is the 3 and 5 first. I can do that. And this would be what I would put into the first box on the homework. Now, the second box is going to say something like simplify with the grouping or something like that, okay? So what that means is you're going to take the 3 and 5 in the parentheses there. 3 plus 5 is 8. So you'd put an 8 in there, but simplified, it would have to show with the plus 6 right there, okay? So that gives us a new expression, 8 plus 6. And then the third box is for the simplified answer, which is just 8 plus 6, and that is 14. So this is what the 3 boxes that you're going to see on the homework. That's where you're going to put in there, okay? But on the second box, you're going to have to show the plus 6 with the 8. Even though it tells you to group, just combine the grouping, you need to show it with the other addition part of that, okay? So this next one, 8 plus 1 plus 6. So again, with the associative property, the order does not change. I still have 8 plus 1 plus 6, but it just changes where the parentheses are. So where it was around the 8 and 1, now it's around the 1 and 6. And again, that would be the first box. So the second box would say 1 plus 6 there is 7. So now it's 8 plus 7. And then 8 plus 7, 8 fingers up, 7 more fingers, 15 fingers. Okay, so that's all 3 boxes that you'll see in the homework right there. That's the first box, second box, third box. And we're going to do the same thing with this last one. Again, the order does not change. You got 20 plus 297 plus 29. And again, if you change the order, that's the commutative property, which is related to the associative property of addition, but it is a little different. So I need to change where the parentheses are. It was around the 297 and 29. So now I'm going to put it around the 20 and 297. So again, that's the first box. I combine the 20 with the 297. Let's just show the work on that. Plus 297. 0 plus 7 is 7. 2 plus 9 is 11. Carry the 1. 1 plus 2 is 3. 317. So that result is 317, but I still need to show the plus 29. And then when I combine those, 317, so that's the new addition part, right? 317 plus 29. 7 plus 9 is 16. 1 plus 1 plus 2 is 4. And then drop the 3. So that ends up being fully simplified as 346. But again, I'm going to emphasize this. It doesn't matter if a problem comes in with parentheses. If it does, you can still move them around the parentheses I'm talking about. But if it doesn't come in with parentheses, you can force the parentheses to be there if you'd like. All right, there's more problems on the homework about this fact family stuff. Now, there's a different way to solve these types of problems. It's called principles of equality. It's just we're not going to go over those, I think, in this class at all. If you take 920 or 950, you'll go over that stuff, okay? Well, for now, we're going to focus on fact families. So there's a relationship between addition and subtraction problems when we're using the same values, right? So A equals B plus C, but that also means A minus B equals C, but A minus C equals B, okay? So let's look at one of the facts that we've seen before, right? I think we saw this one, 29 plus 0 equals, I'm going to make the other 29 a different color just so we know where it is, okay? In fact, I'll change it so it kind of matches the format here. This. Okay, so this is like the 29 in purple there is the A, the black 29 is a B, and the 0 is a C, right? So you could rewrite this if you wanted to as the A is 29, so it's 29 minus the black 29 equals C, which in this case is 0, right? And that, hopefully we know that that's a fact. 29 minus itself is 0. But we can do the same thing with this last one. The A is 29 minus the C value, which is 0. That equals 29. Now, what's going to happen is they're going to show blanks on the homework. Of course, you could use the phantom zero property for addition, right? The identity property of addition to solve stuff like this. But if this was a blank right here on this one, you could use fact families to solve, okay? Now, of course, yeah, the identity property works as well, so you know that's a zero, right? But we're gonna see it where it won't be applied with the identity property of addition. But we may have to do some analysis on this. So sometimes it sets up more like, like we've seen before, B plus C equals A, like this. Okay, well, that still means that A minus B equals C. But yeah, that may look a little different, may look like C equals A minus B, okay? So this also means that, see how it equals C? It doesn't matter if you put equals C here, or equals A is on the left, we can put equals A on the right as well, okay? It's just gonna equal that individual value. So here we go, we got 1, 2, 3, 4, 5 examples, okay? And I got the fact family up so we can use that to figure out the answers to these ones, right? So this first problem here, 50 equals something minus something else. That looks like this one right here, okay? That's what I'm gonna say. You could say it's this one, and that would be fine. So it's really, I'm gonna rewrite it in this order, A minus B, so it's 98 minus something equals C, which is 50 here, okay? So the fact family, that's the middle one. So I'm gonna use the top one. So that's A, that's 98, would be the same as, I guess, B, which we don't know, plus C. So that would be that fact, a part of the family. Then the bottom one would be 98 minus that C value, which is 50, which now equals the blank, which is the B. Now, I've listed all three of these. Okay, we started with this one in the middle. We made the red and the green one. But we may ask ourselves, sorry, I put the C there. I meant that should be 50 right there. Sorry about that. We may ask ourselves, which of these three is going to help us the most? Well, if it gives us another blank with the operation, then it's no good. What we want is the two values being operated on each other. So that's the green one, right? 98 minus 50. And yeah, we can perform that operation right there. 98 minus 50. So 8 minus 0 is 8. 9 minus 5 is 4. So yeah, that would then fill in this empty space with 48. Now you could just double check, right? You could say, well, is 98 minus 48, does it actually equal 50? Let's check. 8 minus 8 is 0. 9 minus 4 is 5. So yeah, it does. The second one is just to check it off. And it does. It does check off. So the answer here is 48 using the fact families. All right, so this next one, blank minus 29 equals 65. So let's set this up. Yeah, and this one kind of looks like that middle one again to me. You could say that it looks like that bottom one too. It doesn't really matter. I'll say it's the bottom one, okay? So A minus C, 29, equals 65. Like this, right? So I can rearrange it. I could say, well, the middle one there would be blank minus 65 equals 29. But again, that doesn't help us because it's not directly operating on the 65 and 29. So let's see if the addition one does help us. So that would be, so that's a C and a B value. So that's A, which is blank, equals B, 65 plus 29. Yeah, this one does, right? Because we can operate directly with 65 and 29. So 5 plus 9 is 14, carry the 1. 1 plus 6 plus 2. 1 plus 6 is 7, plus 2 is 9. 94. So 94 minus 29 would equal 65. And there's that second one. All right, this next one, 36 plus blank equals 68. Yeah, that's the top one because it has addition. There's only one addition fact in the fact family here, so we're going to show this as, again, I'm going to kind of change where the equal is. 68 equals 36 plus blank. All right, so again, we're identifying the A, B, and C values here. So we can kind of plug them into these formulas, essentially. So the A is 68. The B value is 36. So minus 36 equals the C. That's the unknown. And we see the operation right here, but I'm going to show this last one just to show that it wouldn't work, or it doesn't necessarily help us. A is 68. The C value is unknown, so that's our blank, equals 36. So again, we should see operations between the two values that are given, and that's what we see here in red with this middle fact, 68 minus 36. So let's go ahead and do that operation. 68 minus 36. 8 minus 6 is 2. 6 minus 3 is 3. So that answer is 32. And again, you can check 36 plus 32 is 68. Let's try that next one. It looks like it takes the form of those bottom two with the subtraction, right? So we would say, I'll use the bottom one again. That's 54 minus blank equals 31. And it takes on that form exactly. So the other subtraction problem would show 54 minus, because that's A minus now the B value, which is 31, equals the unknown. And again, we see the direct operation between the two values there. But again, I'm going to show the top one just to show it wouldn't work. 54 equals the B value, which is 31, plus the C. But again, it's not a direct operation between these two. So we can work with this middle one. Right here, this one. 54 minus 31. 54 minus 31. 4 minus 1 is 3 in the ones place value. 5 minus 3 in the tens place value is 2. So we get 23. Let's set up this one. 96 equals blank plus 32. That's the addition problem, right? So it's a 96 equals blank plus 32. All right. So again, we can identify the values as they are, A, B, and C. So the next one would set up as, well, A is 96 plus B, we don't know that value, equals 32. All right, well, again, that one does not show a direct operation between the two numbers. So let's go to the third one. Oh, I put plus, that should have been minus right there. I apologize. So this last one would be 96 minus the C value, which is 32, equals the blank. That's the one that we want. So we'll do this one, 96 minus the 32. 6 minus 2 is 4. 9 minus 3 is 6. So that's 64, which I can put into that last blank. All right, now I've strictly used the fact families to solve these types of problems. If you understood the principles of equality, you're like, I know I need to add and subtract both sides, feel free to do that. But I'm not going to cover it here because, again, we're focusing more on just the algebra of it all. Now, there is another way to do this. It's just, it generally requires more time, which may provide an inconvenience to you. So what I'm saying here is that you could use guess and test on this stuff. You could say like, 98 minus, 40, for example. You'd say, okay, 98 minus 40, and then you'd do the calculation down here, and you'd get 58, right? Then you'd know you'd need to adjust your 40 accordingly. Sometimes you have to adjust up, sometimes you have to adjust down. But you can find the answers that way. It just, you're going to be doing a lot of subtraction, maybe some addition in the way like this one, like 36 plus what is 68? I don't know. I know 6 plus 2 is 8. Then 3 plus 3 is 6. And you can work by place value that way as well. All right. But again, that's going to take some work. It's going to take, I don't know that it takes more thought process, but it takes some thought. Okay. But again, feel free to do that if you feel more comfortable in using the guess and test method for now. But we will create a more systematic way to do this so that it's something that you can use every time. I mean, you could use the fact family every time, but again, it can consume a little time because you got to set this up and then see which one works out the best.